Alright, so for the first part of this, we've added sodium to all these little test tubes, and what we're going to do is we're going to look at the effect of, see if there is a reaction between the individual organic compounds and the sodium metal. So the first one we're going to start with here is ethanol. So ethanol here is an alcohol. I'm going to add a few drops. And what we see off the bat when we add the ethanol is that we do begin to see a lot of this kind of foaming around it. Now it's going to take just a minute for some of the reaction to take place if it is going to occur, just because we have to wash the mineral oil off the sodium. But we definitely see it kind of like floating around. So there is a reaction with ethanol. Then we go to propanol. So the 2-propanol and our alcohol, and maybe a little hard to see here, but there's definitely a little stream of bubbles coming off the sodium metal, but it's definitely not nearly as pronounced as we saw with the ethanol. So this is a much slower reaction. Now we're going to add the tert-butanol. And our tert-butanol, we add it, it's probably again very hard to see on your end, but there's a very fine stream of bubbles coming up from the sodium. This is not nearly as pronounced as was the ethanol or the 2-propanol, but we do in fact see a reaction. This is the production of hydrogen. So now let's move on to cyclohexane. So cyclohexane, it's just a standard run-of-the-mill alkane. Take it and we add our mixture to it, and what we don't see is any reaction with the sodium. So no bubbles are formed. Now we do cyclohexene. And we add the cyclohexene, no reaction. Next compound we're going to add here is the hexanes. So this is a linear alkane. Add it. No reaction with the sodium metal. The hexene. We don't see any reaction with the hexene. Our last one here is our toluene. So we have the toluene, and again we don't see any reaction. So when it comes to the sodium metal test, we don't see any production of hydrogen or any reaction with sodium except when we're working with our alcohols. So what we're going to do here is we're going to focus on our 2 alcohols, and to these we're going to add a few drops of phenolphthalein, and this is a pH indicator that turns pink under basic conditions. Now we're not going to add it to these because this contains some methanol, and we know methanol is going to react, so give us a false positive. So if we add a drop to the ethanol, we see it turn this pink color, indicating that the solution has gone basic. For the isopropanol, we add a drop. That's also turned purple, or yeah, turned our deep violet color. And our tert-butanol, add a little bit, and we also see that color change. So in the case of the compounds which did react with sodium, we see the switch to a basic solution. So that's our reaction with sodium and the subsequent effect on the pH of the solution.